Hello, it's Mr. Kablan here again, and I'm here to present the last lesson for chapter 5. And this will be now I call this lesson putting it all together. And the reason why it's called putting it all together is because we're now going to connect slope with the rate of change, with the first differences, and all the stuff that you learned in the 5 previous lessons. However, before we do that, I just want to do a quick summary of what we have covered so far and how it ties into today's lesson. So as you can see here, what I have here is my little formula board over here with a lot of arrows and a lot of things that we've covered. So where we left off 2 lessons ago is we learned a second way of calculating slope using what I refer to as the fancy formula. So when you're given a graph with big numbers, or if the graph that's given to you isn't going up by 1, or any type of word problem, or in a future lesson when you don't even have a graph, that would be the best way to calculate the slope of a line, the y2 minus y1 formula. Now, what we're going to do for today is like I said, we'll be revisiting all of that, and then you're also going to learn a third way to calculate slope using another method as well. Now, back when we were doing partial variation, you learned the letter B to be what's called the initial value, okay? Or basically where the line crosses or touches the vertical axis. What you're going to see in today's lesson here, when we're dealing with this letter B, you're also now going to be referring to it as what's called the y-intercept, all right? And the definition of y-intercept is where the line touches the y-axis, which I've said several times. So you're going to see all of that. And again, all these words that you see on this screen over here, okay, that are beside each other, they're basically the same thing, just another way to say it. So for example, x-axis and horizontal axis, it's the same thing. Same thing with vertical axis and y-axis. Guess what? It's the same thing there. All right, so what we're going to do here, again, this is a summary of what we've covered up until this point, and then we're going to add to it after today's lesson here. All right, so speaking of today's lesson, let's get to it, and let's talk about what it means to connect all the things we've looked at in this particular chapter. So if you take a look at the title here for a moment, okay, the things that we've covered up until this point have dealt with variation, the 2 types, direct and partial, okay, and we learned how to calculate what was called the constant of variation, which was the calculation of rate. And in a later lesson, we tied in slope and how that tied into the rate of change as well, and how they were exactly the same thing. Now, today's lesson, we're now going to tie in what we did from the last lesson when we calculated the first differences. And we're going to relate that and then connect it back to the previous 2 things that we did in this chapter here. All right, so like I said, in today's lesson, we're basically going to literally put everything together and then just get a bigger picture of what we have seen in this particular chapter. So in the last lesson, you learned what was called the first differences, which is calculating the differences of the y values in a table of values. When we're looking at what are called finite differences, okay, it's also going to tie in not only just the values for the changes in y, but we are also now going to factor in for the changes in x, and I'll tell you exactly when we get to do that. All right. So as I mentioned several times already, when we're talking about constant variation, rate, and slope, those 3 things are all exactly the same thing, just used in different contexts. And that's exactly what this particular statement tells us over here. So if you take a look at this and read it word for word here, okay, the following also represent the slope of the linear relation. And like I said, slope itself is all these things that's listed here. So again, slope, constant variation, and rate of change are all the same thing. Now, as we also mentioned, slope m, okay, can be calculated several different ways, and you've learned 2 of them. So the first one here was using rise over run. Now remember, we use rise over run when we're given a graph and the numbers or the boxes are going up by 1, and you just count, right? So that's rise over run. Okay, the next thing we're going to look at, and this is what today's lesson is about, is delta y over delta x. Now, what the triangle or the delta represents, okay, is a change in something. So in words there, what we're going to look at in today's lesson is we can also calculate slope using the change in the y values over the change in the x values. So today's lesson is going to focus on this particular aspect of calculating slope. All right, so that's the brand new thing that we're going to look at in today's lesson here. And in fact, this is the third way that you can also calculate the slope of any type of relationship. But like I said, we're going to go through into detail once we get through that example. All right, and in the 2 lessons ago, you learned this fancy formula to calculate slope using this formula here, where you would be given 2 points, and then you label the 2 points as x1, y1, and x2, y2, and then you substitute it into that formula there. So these are the 3 ways that you can calculate the slope of a line. Now, what we're going to also tie in is the equation of a line, okay, given in the form of y equals mx plus b. Now, I mentioned this in a previous lesson, uh, specifically the one dealing with partial variation, is that this equation here is going to carry you through not just this chapter, which you've already seen, okay, but also throughout the next chapter. So just remember to keep that particular equation handy. Now, remember that what we've seen with this equation in particular is that the m represents the slope, okay, which you've learned to calculate in 2 different ways up until this point, okay, and the b, okay, represents the initial value or the vertical intercept. Now, remember the vertical intercept, or sorry, the vertical axis is the axis going up and down, which you also knew to be the y-axis. Now, from this point forward, we're also going to refer to this particular intercept as the y-intercept. And the reason why it's called a y-intercept is because we're going to see that where the line touches the y-axis, okay, that point is going to be that intercept, the y-intercept. Okay, so a lot of new things that we see here just in this one screen alone. That's why at the end of today's lesson, we're going to wrap things up in this chapter with that little board I made, so you can see exactly what the different words mean and which ones are the same. Okay, and again, definition of y-intercept is where the line touches the y-axis. So you're going to see again that when we're seeing some questions, we're going to see where the line touches the y-axis, okay, and that will be our y-intercept. All right. Okay, let's get right to it here, and let's take a look at the first example. And what we're going to do with this example is take a look at all 3 types of variation and how they are related to each other here. So you can see what we have here is a table of values. And what we're going to do here is break this step by step so you can understand how we can use the change in y values over the change in x values to determine the value of the slope of this chart right here. So step first, let's go back to the basics and let's graph this. Now remember that what we have here for each case over here is that for each pair of x and y's, what we have here are ordered pairs. So we're going to plot the first point here at 0, 5. Next one here is 2, 9. So we're going to right 2 and then up 9. Okay, we have 4 and 13, 6 and 17, and last but not least, 8 and 21. So we plotted all 5 points there. That's going to give us a straight line. All right. Now, don't forget, always extend your line straight through just in case you have to do interpolation or extrapolation. But we're not going to do that in this lesson, but just a reminder as well. All right, for part B over here, it says, is this direct or partial variation? Now remember graphically, the difference between the two, okay, depends on where it starts or where it crosses the y-axis. So if you take a look at this graph over here, you notice that this graph starts at somewhere else other than 0. Specifically, it touches the y-axis here at 5. So since this particular line does not go through the point 0, 0, this would be an example of something that is partial variation, and that's exactly why. The line does not start at y equals 0. Okay, so anytime you see a line, whether it's going up to the right or down to the right, okay, if it touches a point other than 0, then it's automatically partial variation. All right, so we have a graph here. We've drawn the graph, and what we want to do next over here is to use 2 points on the graph to calculate the slope of the line. Now, if you take a look at the values for the horizontal or x-axis, you notice that these boxes here are going up by 1. Okay. However, the boxes for the y or the vertical axis, notice, are going up by 2. So the best way to do this, using the best way to calculate slope of this, okay, even though you might try rise over run if you want to, it's probably not the best choice. Okay, we're going to use the formula y2 minus y1 over x2 minus x1. Okay, so I'm going to randomly pick 2 points. Like I said, this is a PowerPoint, so I picked them already. So I'm randomly picking the second one, which was 2, 9, and I'm randomly picking the one right beside it, which is 4 and 13. Now, when you calculate the slope of a line, you can pick any 2 points on this line to calculate the slope of the line, and you will still get the same answer, provided that you do the math correctly, of course. All right. So step number one, always start off by writing in the formula. And like I said, we're going to use our fancy formula for this one. Now, before we proceed here, let's think of a moment what the direction of this slope will be. So remember that since this line here is going up to the right, we will have a positive slope once we finish the calculations. All right, let's finish this question over here. So remember, you always label the first point. Label the points from left to right. So this first point is going to be x1, y1. Okay, second point is going to be x2, y2. Again, whatever you do, do not change the order. Always label the first point as x1, y1, and the second point always as x2, y2. All right, next thing, we're going to replace the numbers into the correct letters. And again, do this carefully over here. So y2 minus 1 will be 13 minus 9, and then x2 minus x1 will be 4 minus 2. All right, so doing this step by step here, I'm just going to simplify this further. 13 minus 9 is 4. 4 minus 2 is 2. And last but not least here, if you take this fraction and reduce it, you wind up getting here a whole number of a slope of 2. All right, now, as you're writing this, I'm going to quickly explain here. If I pick, for example, the first point, okay, and the last point, okay, you will still get the same slope. You will just have different numbers in the in-between steps. But you will still get the same answer, again, provided that you do the math correctly. All right, so now that we've calculated the slope of this line here, which is 2, what we want to do now is to use the chart and answer the following questions here. So it says, look at the given table, which is the one on the left side here, okay? It says, describe the pattern in the x values. So if you take a look at the x values, and as you go from the top all the way to the bottom, okay, you should notice that this here has a pattern. In fact, it's a pattern where all these numbers here are going up by 2. All right, so in the previous lesson, when we were doing the lesson on first differences, remember we just did a check for this one, just an informal check just to make sure that all the numbers are going up at the same amount. In this particular example, we actually are going to be using this amount to calculate the slope here, so just bear with me. All right, so you can see here that each of these x values are going up by 2. So the next thing we're going to do here is to answer question number, the little dotted I2 here, is calculate the first differences in the given table. All right, so in this case over here, what we're going to do here is going to find the differences of these numbers over here. Now, for those people that are really good just looking at these numbers, okay, notice that as we go down these numbers over here, each one of these numbers is going up by 4. But let's just double check here, all right? So 9 minus 5 is 4, okay? I'm going to take the 9 subtracted from 13. That's also going to give me 4. And you can see that all the numbers here will give me 4 when we're subtracting the successive y values here. So again, what we have to do here for this one here is now factor in these two numbers. Now, I want you to take a look at exactly what we've done here, because I want you to understand what the formula is for section 3 over here. Okay, notice the first differences are 4. Now, what the first differences are, if you look at this formula on the right-hand side here over here, the first differences are also is also the same thing as the change in y values. And that's why when we're looking at these numbers over here, I mentioned several times that you're looking at the change or the difference in of the numbers in the y column. Okay, so the change in y, that's going to be the 4. Okay, if you take a look at this one over here and you look at the formula that you have in section 3, where I have hovered my cursor on, this 2 over here would be the change in x values. So going to question 3, it says calculate slope by using m equals the change in y values, okay, over the change in x values. And you're going to see in this case over here, okay, I put the same numbers in. I put the 4 in for the change in y, and I put in the 2 for the change in x. And as you can see, this looks familiar because we actually saw this in the last example. So what we have here, guess what? We get the same answer as the previous example. So just to tie in what we've done so far over here, you notice that what we've done is we drew this line. Okay, we did it the basic way first. We drew the line. We picked 2 points. Use rise over run to calculate the slope. Now, if you notice, we use a second method, which is the new method for this particular lesson, where we use the change in y values over the change in x values, and guess what? It gave us the same answer. So notice that we're just dealing with the same question, and we're just reinforcing the fact that this formula over here and rise over run are exactly the same thing. But again, it's just used in different kinds of scenarios. Now, common question, this formula over here, the change in y values over the change in x values, common question is, how do we know when to use that particular formula? Well, anytime you're given a table of values, this thing over here, okay, anytime you're given a table, okay, to calculate the slope, you always use this formula, okay, and it's the only time that you can use this formula. Okay, so when you're given a table, like I said, okay, write down the formula and just remember that the change in y values, that's the first differences over here, okay, and the change in x values, that's this part over here, the 2. All right, so as long as you understand when to use that, okay, then you should have no problems understanding when to use rise over run, when to use the fancy formula, okay, and when to use this. All right, so again, now you've seen how the 3 different calculations for slope work and when to use them. Like I said, when I finish this lesson, we're going to wrap things up by going back to the board to summarize all the formulas that we looked at in this chapter. All right, moving on here, still on the same question. For part E, it says look at the graph again, and what is the initial value? And it says in brackets, look at the y-intercept. So if you take a look at this line over here, you see where the line touches the y-axis. Now, notice that when we graph, this was the graph that we did in the first example here, and we're just strictly looking at this. So notice that this point here touches the y-axis at 5. All right, now, this last step is very important because, like I said, this is now going to be the foundation of where we're going to start off in the next chapter. It says use the slope and the initial value y-intercept to find the equation of the line in the form of y equals mx plus b. So what we have from the previous 2 examples is a slope of 2. That's going to replace m. Okay, the y-intercept is going to replace the letter b. Now remember that the b we know now as the initial value. The vertical intercept, okay, now we see it as the y-intercept, and that's always going to be the letter b. So the equation of this line is going to be y equals 2x plus 5, all right? So let's just recap as you're writing this over here. Again, we got the slope by calculating slope. Actually, we actually did it 2 ways, using rise over run, okay, and then we also used the table just to double check it by using the change in y values over the change in x values, okay, and we just looked where the line touched the y-axis, and we noticed it touched the y-axis at 5. All right. So notice that we spent time on one question just to look at different ways to calculate slope and how we can figure out the y-intercept simply by looking at where it touches the y-axis here. All right, moving forward. In this example, we're going to do something very similar. We have a table, okay, and we're going to do the exact same thing. Okay, we're going to look at the table, plot the points, and then calculate the slope using our fancy formula here. All right, simply because I want you to get used to using the fancy formula to solve for slope, and I just want to make sure that you're comfortable with using it. All right, so let's first plot the points first. So starting off with 0, -2, okay, 1 and 3, okay, 2 and 8. 3 and 13, and 4 and 18 up here. All right, and let's connect those with a straight line. All right, so for part B, it says use the graph to calculate the slope. Again, we could have used rise over run. Notice the numbers are going up by 1. Like I said, we can do it, and you can do it for this example. However, I do want you to get used to using the fancy formula, so we're going to use that. Now, again, I've randomly picked points for this example here. So in this example, I randomly picked the second point, which was 1, 3, and I randomly picked the fourth point, which was 3 and 13. Now, as I mentioned in a previous example over here, you can pick any 2 points on this line, and it will still give you the same answer. Again, provided that you do the math correctly. All right, so using our fancy formula, okay, always label the points accordingly. Now, before we do that, let's talk about what the slope should be direction-wise. As you can see, we have a line that's going down to the right, or sorry, that is going up to the right over here. So what you should have here will be a positive slope. All right, so always label the first point here as x1, y1, and the second point is x2, y2, okay? Don't change that. Whatever you do, don't change that. Keep it nice and consistent there. Again, you always label the first point as x1, y1, and the second point is x2, y2. Now, always label on the graph here because it helps you see where the numbers need to go in the formula. So if you take a look at y2 minus y1, what you have there will be 13 minus 3. And for x2 minus x1, you will have 3 minus 1. So 13 minus 3 is going to give me 10, and 3 minus 1 gives me 2. And last but not least here, you can, since this is an improper fraction, you can reduce it, and it actually gives us a whole number here of 5. So the slope of this line here is 5. All right, for part C, what is the y-intercept? So we just need to see where the line touches the y-axis here. So notice that if you take a look at this line, it touches the y-axis at exactly right here. All right, so from there, that's going to give us now enough information for us to finish this question. So for part D, is what is the equation of the line in the form y equals mx plus b? So all we're going to do here is we're going to take the 5 and we're going to substitute it in for the m. And we're going to take this -2 and then substitute it in for the b. Now I'm just doing this step by step here because I want you just to get used to the form behind it. So in the next line here, I'm going to replace the 5 here, the m, and I want you just to see what I'm going to do with this b of -2 over here. Now you notice I put the -2 in brackets just to get you used to the convention of putting or substituting numbers in for variables. Now, just as a reminder, okay, whatever you do not leave two signs side by side like this. Whenever you have a positive and negative, remember the rules of integers tell us that when you have a positive and a negative side by side, that changes itself to a negative. So your final equation or your final answer for the equation of this line will be 5x minus 2. All right. So again, just to summarize what we did here before we proceed to the next example. Again, we plotted the points first using the table and ordered pairs, calculated the slope by picking any 2 points of a line. Okay, and we just looked at where this line touches the y-axis to determine the y-intercept. Now, I also just want to remind you, when you're coming up with the equation of the equation of the line, you are only replacing the m and the b. That's why the equation of the line is always going to have the y and the x as part of the solution. All right, let's move on over here. So the next thing we're going to do here, we're now going to look at a word problem that's going to apply what we've done throughout this entire chapter here. So what we're going to deal with here is gas consumption. So it says here, the graph shows the relationship between the volume of gasoline remaining in a car's fuel tank and the distance driven. All right, so just talk about the graph here first. Okay, so if you take a look at the graph, something that's a little bit peculiar about this, first of all, if you look at the horizontal distance, okay, which is designated by the lowercase d over here, notice that every other box is going up 200. So, you know what? Big numbers and going up a different number amounts. So that tells you something. Okay, also notice that the scale for the volume or the vertical axis over here, okay, notice the numbers here are going up by 13. So rise over run, definitely not an option for this one. All right, so it says here for part A, use 2 points on the graph and use the formula, the fancy one, to calculate slope. Now, before we do that, let's talk about the line for a moment. Okay, notice that this line here, okay, is falling down to the right. So remember that any line that falls down to the right, okay, will always give us a negative slope there, all right? So our answer, we should anticipate that it's going to be negative. So we're going to use our fancy formula for this one. So start off by writing down the formula. Okay, and when we do that, before we write down the formula, that is, always pick 2 points. So I'm randomly just picking this this one in the middle over here. So this is the point 239. Now, before I proceed over there, why is it 239 and then not 39, 200? Remember, when you have an ordered pair, you always put in the value for the x first. Now, in this case here, the x happens to be this lowercase d. Okay, so that's why the 200 is in the first spot, and the 39 would have been the y, but in this case here, it's the v, so that would be the second spot. Okay, so just think about the values either as an alphabet if you have x and y, or in this case over here, okay, the horizontal axis is the first number, and the vertical axis is the second number. Okay, x and y is probably the easiest way that most people remember it. All right, my second point, I've randomly picked this one over here, which is 413. All right, now, as I said before, our slope needs to be negative, so let's use the formula to do that. Now, remember that when you're labeling, okay, and in this case, we still have a graph to work with, always label the points from left to right. So This is the first point on my left side here. So I'm going to label the 200 here as the x1 and the 39 here as the y1. Why? Because it's the first point that I see from left to right. Okay, always stay consistent. Make sure you're labeling things from left to right. Okay, because again, it just avoids any problems in the future. All right, 413 is going to be x2 and y2. Now, for this one over here, just to be careful, notice that once I replace the y2 for 13, okay, and 39 for y1, okay, that automatically gives us the negative that we were looking for when we were talking about what the slope should be. So 13 minus 39 gives me negative 26 over 200. And that fraction, when you reduce it, gives us negative 13 over 100. All right. So it says here, what does slope you represent in this situation? Now, again, think about gas here for a moment. I know grade 9s are not at the age to drive yet, but basically, as you drive, okay, the volume of the gas decreases. So that makes sense that this line here is going down to the right, and it makes sense that the slope here is negative. What we want to do here is just interpret in words what these two numbers represents and how we can also explain the negative when we're coming up with the sentence for this word problem. So the volume of gas lost used for every kilometer traveled is what's represented by this slope over here. So when we are trying to explain it in words over here, one way you could say it is that you are using up 13 liters of gas for every 100 kilometers. So that's just putting into words what's happening with the slope here. Okay. Like I said, that's just a way to explain in words so you understand the context of how slope is used for this particular problem. All right, so we've calculated the slope. We now understand what slope is. So the next thing we want to do here is to find the y-intercept or the vertical intercept and come up with an equation for this thing. All right, so what is the vertical intercept? So we're just going to look at where this line touches the vertical axis, the y-axis, which in this case happens to be a v. Okay, and guess what? It's this one over here, the 65. Okay, so let's put this all together. We have a slope of negative 13 over 100. And remember that the vertical intercept or the y-intercept, that's going to be the letter b. So all we're going to do here is take this negative 13 over 100, replace it in for the m. Take this 65, replace it in for the b. So the equation of this line that you have here will be y equals negative 13 over 100x plus 65. Now, just a reminder that you always express your, if you have a fraction, okay, always express it as a fraction in lowest terms, okay? The only time that you are to convert it as a decimal is if you're, number one, asked to do it, or in the context of the question, there happens to be a decimal that makes sense. So questions dealing with money, for example, okay, as an excellent example where you can use a decimals for a slope there, okay? So just I know people are always asking that, so I just want to bring that to your attention there, all right? All right, so that wraps up the lesson here. As I said before, if you work through the review questions, okay, that will be a suitable replacement for the textbook questions. However, before I end today's lesson, I just want to do a quick wrap up and quick summary of everything that we've covered in this particular chapter here. So let's go back to our little formula board. So up until now, this is what we have seen. So again, what we have here are all the formulas you do need to know and memorize for this particular chapter. Now, one additional thing we're going to throw on, now that we've moved this over, is you now learned a third way to calculate slope over here. Okay, and we're going to write it down right here. And I've magically hidden it right here. All right, so and this will be a nice little summary to all the things that we have here that we've covered in this chapter. So like I said before, when you're looking at the b, okay, that was the initial value where the line touches the y-axis, and now you know this is the y-intercept. Okay, when you have a graph, a basic graph, okay, the easiest way to calculate slope would be rise over run. Okay, so for example, if the numbers are going up by 1 for each box, use rise over run. All right, if you have numbers that are big or the scale is not going up by 1, that's when you use the fancy formula over here. Now, this last one over here, the change in y values and change in x values, okay, the only time that you should use this one over here is when you're given a table of values here, all right? So the calculation for slope, as you can see now, you have learned 3 different ways to calculate it. Okay, so when you if you take a look at a moment at this board, okay, feel free to screenshot it. Like I said, this one board right here is a summary of all the formulas that we looked at in this chapter, and these are the formulas that you are expected to commit to memory for this course here. All right. So that not only wraps up this lesson, but it also wraps up this chapter, and I will see you in chapter 6.